Yesterday,
Yesterday you received.
after the time.
And have you took the appointment for written exam?
No, did you?
No. But I will check this week.
Okay.
And also we need a blue letter.
Yeah.
Destroy the river and the recording because I was like, you can't say anything in the recording.
Excellent.
Just a brief summary what we introduced. The canonical transformation in chapter 9.
space, so we build up this Hamiltonian, and this the Hamiltonian equation motion gave us solve the solution for the general coordinates and the canonical momentum from the top of solving this. But we know to solve this is still difficult, even though it is the first order differential equation, but it's a cross term, right? So our goal is try to find the general way, try to simplify this solving these difficult equations. And the way or idea is come from here. We know the Hamiltonian depend on choice of general coordinates. So that means if we select another set of general coordinates, we can change this expression Hamiltonian such that in this case is Q in separate. So in such that if we select new set of general coordinates such that convert to the new Hamiltonian, which if this is circular, right? So the way is, suppose we can convert to this or transform to a new side, then the new side Hamiltonian's new expression in terms of new side of general coordinates, then they correspond to the Hamiltonian equation motion, similar, but this is partial with respect to this new Hamiltonian. Then if that is more interesting, the goal is if we can convert or transform to a new set such that the Hamiltonian K, in this K, that all the general coordinates are cyclic, then all the conjugate momentum are constant. Then that means the K is only a function of constant, we use alpha j. So then you substitute here, this is 0, it's a constant, and then we solve this one. And of course, if in this case, we also assume that K does not depend on time explicitly. So this one became only a function of alpha. Then we can do the integral and find this general coordinate Q, capital QJ, is sum of the constant which we call that is kind of like omega is speed, right? Multiply time, and then plus this initial condition. So once we this solved, we can go back to get this solution by the transformation equation. So that is the idea, how we introduce the canonical transformation. Then the question is, how can we know our new set of general coordinates or canonical variables are, the general coordinates are canonical variables. So that condition is that, how can we transform that from the old one to the new one, which is still the canonical variables? The capital QG and PGs follow this. So the condition here we discussed last time. The condition is from this Barton principle or Hamilton principle. We obtain the left-hand side is a function of all general coordinates, and the right-hand side is a new one, the function of new general coordinate, then plus arbitrary function total time dt of df dt. This one is key. Because this one, as I said, is any function in the phase space. So there's no any restrict on what kind of function, but only function of general coordinates and the conjugate momentum. That's all. Then, if this function is continuous after the second order derivative, the most important is this function must be mixture of the old and new canonical variables. So this play as a bridge between the old and new, such that we can make the transformation from old one to new one. So that is the idea. And now today we are going to discuss. Okay, since this is a key, right? We call the generated function. So we are going to select which type of generated function and what kind of. When we select different type, that different type is different type of mixture of this, right? How to mixture the old and new, and then we have a given type of f. Then we're going to come to substitute into this canonical transformation equation. Then this equation will reduce to a simple case, right? So now we are going to do this. So there are 4 types. That does not mean only these 4 types. There are more others, but we just focus this 4. Then we can discuss some general. Okay, F1 type. F1 type is if the function is equal to F1, which is the old general coordinate is Q.
half, right? And the half of old, right? And the half of new is also general coordinates. T. Also maybe depend on type, right? So you see, this is a type that's only the general coordinates half of new one, half of old one. So that is F1 type. F2 type is now, let's see. I will not do this. Just things. So F2 type is that if the function is mixture of the old general coordinates with new conjugate momentum. Right? This is another type of a mixture. Old one. So this F1, F2, you can see here, we keep the old one, always take the general coordinates, but the new one, either the new general coordinates or a new conjugate momentum. Then you can take another type of mixture, right? F3 is a mixture of old conjugate momentum with new general coordinates, or F4 type is another mixture of old conjugate momentum and new conjugate momentum, right? So you can see this is a mixture of the how to mix this, but we can also make this a mixture of this F1, F2, or F1, F3. So let's just start to discuss this each individual, then we can take some examples, see how if we mix these four types together. So let's first consider the F1 first, and then we spend the time to discuss F1 in details. Then F2, F3, F4 is very similar, but a different form of equation. Right? So now let's consider F1 type. Let's consider this case. Okay. So F1 type means if we select F is F1 type, then there is a function of old general coordinates and new general coordinates like this, right? Okay. So if we select this, because here is a total time derivative, right? So we are going to calculate this one. Once we have variables, we know how to do this, right? So since total time derivative of F df dt is df1 dt, then you can see here this is this term, so that is summation. Okay, summation j and the partial f1, partial qj to the dot, right? The first is, and then second is for the second half is a partial f1, partial capital qj dot, and partial f1, partial t, right? That is total time derivative. Since we are going, when we select that general type, generating function, we are going to substitute here and to apply to this equation of canonical transformation. Okay. So we substitute the df dt into that formula. Okay, the left hand side no change, right? Pj qj dot minus h qj t. Left hand side. Then the key is the right hand side. We have a df dt. So right hand side, this the first term is still key. Capital Qj dot minus k capital Qj capital Qj t plus, okay, so now let's substitute this one, right? So that is summation j partial f1 partial qj dot plus summation partial f1 partial capital Qj capital Qj dot plus partial f1 partial t, right? So what we did is just substitute df dt into this equation. And now, since they are equal, so left hand side is equal to right hand side. Okay. Now you see here, left hand side about qj dot This term has a QJ dot. This term, do we have a QJ dot? It is not function of QJ dot, right? Because H is only function of QJ and PJ. Then here, this function is also not function of QJ dot, right? And also not function of capital QJ dot. So capital QJ dot only this one, right? This one is also because F1 is only function of variables, not the general velocity. So now if we set up this equal, this term is equal to this term, right? The coefficients we same. And this term is equal to this term, right? So we have, you can immediately know this is a PJ, this PJ coefficients equal to this one, right? Equal to partial F1, partial PJ. The first one, got the condition. Second, this one and this one. So that is a capital PJ equal to negative partial F1, partial F2, here from 1 to n. Because we need to satisfy this equation, both sides, this be coefficient be equal, right? So we have this condition. Then after this condition, you will see here, this term cancel, right? So this equation will reduce to, the left-hand side is negative Hamiltonian QJ, PJT, right? Only this term. Equal to right-hand side is negative K, capital QJ, capital PJ, P, and plus this term, right? So you can see here, once we use the F1 type, this equation, condition for canonical transformation, this equation reduced to here. Now I'm going to organize, so I move the K to the left-hand side and H go to the right-hand side, so that is what this means. How to find the new Hamiltonian. We know this one, right? That's the initial. We know this since if we know the function, generating function, then we just do the partial, so then we come up to this. Right? When we have this, of course, the details stories later I'm going to discuss the details. Once we know this, we are going to solve this Hamilton's equation of motion in the new general coordinates. And when we solve this, we'll go back, find the relation between this and the relation between this, that is transformation equation, then we solve. Our goal is to solve this one, right? So our goal is try to find finally QJ, P, and PJT, right? That is a solution. This is our goal. How to do that? We from here, go to here and solve this one and come back to here. So, okay. Now the first, we obtain the equation of transformation, canonical transformation is follow this. If we select F1, we just use this to get the K. Okay. Now that is a strategy. That is the equation. Now I'm going to say. So how many equations? There are one equation. Okay, so this is equation 1. Equation 1. Equation 2. And equation 3. So we have 3 equations. If we select F1, right? Select the generating function F is F1 hat. Okay, so this is in 3 equations. Once we know F1, we know how to calculate or construct the new Hamiltonian. We have these 2 equations, and these 2 equations help us to find the relation we call the transformation equation between old and new, right? So this one helps to find this. This is a transformation equation. Equations. That is the transformation between old and new. And this is a new Hamiltonian. Then when we solve the new Hamiltonian, solve the solution for capital QJ and the PJ, then come back to here, substitute here, and make it. So that is the idea. Okay. Now I'm going to give you the strategy, then we go to the details. So the strategy will go, right? Or let's just strategy. Strategy to solve this Hamilton's equations of motion. Okay, how to do that? So first, okay, so first, let's use capital R. First, find the transformation equations that this. Try to find the relation between mu and old. How to find what I'm going to give you details. Try to find this. And find this one from this two, right? From F1. Let me just say that. And then how to know the details. So that is the first step. If we obtain the second one, once we obtain, then once we have, so we apply the equation of canonical transformation. This one. Find this new Hamiltonian, right? So that is the old one now here. Here, this is a old, right? This is new. But here, you are going to, because we have found this, you are going to transfer the old coordinates to new one by this. When you substitute Q, so here I'm going to use Q is function of capital QJ, capital PJ, half, right? If we know, so that's the first step. First step, find the transformation equation. Then the Hamiltonian is an old function, canonical variables. Now, since we have the transformation equation, so we can substitute. Right? And plus partial F1, partial T. Now F1 is also function old one and new one. So old one, we are going to use this transformation equation. So I write this way, you can see here. This equation, left-hand side is a function of the new canonical variable. Right-hand side, this one function, old one, and this mixture. So we are going to replace old one by new one. How to replace from this transformation equation? So here, you're going to replace, then you can see, with this one, you will have the right-hand side are also function of new general coordinates, right? And the conjugate movement, so we get this one. That is how we do. That is second step. And third, once we have this, so we are going to this apply Hamilton's equation of motion. Capital J is partial K partial capital PJ, and the capital PJ dot is minus partial K partial capital PJ. So we are going to solve this. So when we apply this, then number 4. So the equations of motion. Then we get the solution. Qj is a function of time. Pj is a function of also time. That is solution in the new phase diagram, phase space, right? So then the last one, convert mu Qj Pj to the old one. Because that is our goal. So then how to use that? You just substitute, use this transformation equation, right? Convert to Roth transformation equation. That is why we first have this. So once we have this, we just substitute capital Qj, capital Pj into this formula. Time, so that's all. That is, then let's get the final solution, right? That is a study. And to reach this, the final goal, there are two ways, depending on whether we have a generating function or the transformation equation. Okay, so now let me, there are two ways. Process. Step. To do that. So there are two ways. If F1 is known, this is the one way, or if the transformation equations are known. But F1 is unknown. Transformation equations are unknown. Okay, so the two ways depend on which initial condition we have. So now let's depend, right? The process depend on these two conditions, initial conditions. So now let's first consider. Consider if F1 is known. Let's consider this case. Okay, if F1 is known, so first go, right, try to find transformation equation. Then the step one. Just do this. So step one is make the goal is try to find the transformation equation. How to do that? Step one. Calculate. Do you remember the equation? Calculate this. So this one, I'm going to say equation 1, equation 2. I need to give for details. Because you know the F1 is a function of old Qj and new Qj, so that be your results be a function of old Qj, capital Qj, t, right? So that is equation 1. And this one, same thing, that is a function of capital Qj is a function of old Qj, new Qj, t. So that is the first step. Since we know F1, so we do the partial derivative. Then we know this partial derivative gives us the relation of this, the formula for this old P old PG and new PG. Okay, that is step 1. Then step 2, we are going to from there to get this equation, transformation equation. So how to do that? You see here, this is we are going to find the Q as function, the new one, right? So here, let's look at this one first. This is a Q, capital QJ, capital PJ. So from this equation, we can find QJ as a function of capital PJ, capital QJ, PJ, right? So that means invert equation 2 and find the QJ, this QJ as a function of capital QJ, capital PJ. That is the way. Of course, it depends on it is easy or not. That is details depend. But in principle, because this is a function relation between 3 variables, but we are going to find the old one, QJ as function new one. So in principle, we can get right. So that is this one, and this gives us the first part of a transformation equation very easily. Now the next one, we are going to find what is the PJ, right? But this PJ is here already. However, this is a function of QJ and the lower Q, old QJ, so we are going to replace this one by new QJ and new PJ, right? So that is Q equation 3, because this is Q to here, right? To equation 1. So then the equation 1, PJ is PJ function, but QJ now is a function of capital QJ, capital PJ, T, and capital QJ, and T, right? So that is equation 4. So these two, up to the step 3, we have reached this goal, right? Okay. So now, next we are going to do this, calculate, try to find this new Hamiltonian by apply the equation of canonical transformation. So that is step 4. Step 4, I combine step 4 and step 5 together. That is here, K. Apply. Equation of canonical transformation. Remember, in the canonical transformation, we have 3 equations: 1, 2, and this one, the 3. Right? This one, we are going to find the new Hamiltonian in terms of the new canonical variables. That's equal to already this one, right? This one. So that is Hamiltonian. But here, Hamiltonian initially is a function of all the canonical variables. Since we already have this transformation equation, so now you just replace old one by new one. So I'm going to write this way. PJ, and T. Since we from okay, like this. You are going to sum this equations 3 and 4. Yeah, 3 and 4. 3 and 4. Into here, right? Because here we need, and also, okay, let's see. 2H and 1, right? That is, when you substitute, then you come to here. That is, combine the step 4 and 5 together, because this is step 4 and 5 together directly, so just partial F1. Now Q1, QJ is capital QJ, capital PJ, P, and that is step 4. Then once we have a new Hamiltonian, actually just this one. So this is here's this one. So step 4 or 5. Step 5 is this one, right? Okay, just say solve. Relations of motion. So that means solve this. And get a solution. So this will have get solution. Last step, step 6. Establish compute the solution from this step 5. QG, that's QG, that's time, that's QG time, and time, which is QG, right? That is our final, and QG. Okay. This is in case if we know F1. So we can follow this step to obtain the equation, transformation equation, then try to find this the K new Hamiltonian. Then we go to solve this Hamiltonian equation motion, and then we can get the solution and go back to the equation, transformation equation. Now, this first, second. Let's see that if the transformation equations are known. So that means we already know this one. So suppose we know, but we do not know F1. So what we have to do? You may say, okay, this already exists. So we'll skip step 1, 2, 3, we come directly to here. Yes? But you need first to check are they canonical transformation. That means the new variables are canonical variables. We do not know. So we need first check to that. That is the first thing. Second one, if we apply this, we need to find this one. We do not have this term, right? So we need to find this. Okay. So if this is the case, step 1, the goal is find F1. So of course, and also check this whether it is canonical variable. So first, step 1, from here. So for example, you have find this one. If there's a F1 exists, so you find this PJ is the function of QJ and capital QJ, no capital PJ. So you're going to find how to find this. Then you can see here, this is PJ, right? Pj, but this is capital P, capital P. So from here, that is function Qj and the capital Qj, right? So that is from equation 1, you can find equation Pj as a function of Qj capital Qj, right? I'm going to give this equation. So if yes, that means it is possible to exist F1 since F1 is a mixture of the old general coordinates and new general coordinates with a P. And yes, it is like this. So find this and okay. And, in most cases it is. Let's do this. So that find this and then the Pj is equal to F1 partial Qj. This equation, okay, let me keep here. Last B, so if this exists. So now from the transformation equation 1, we try to find the function of the lower Pj, the old Pj, as a function of old Qj and new Qj. Then according to if there exists, then follow this. If suppose if this exists, then we have this, right? We have this solution. So that's step 1. Step 2. Step 2 is from 3 from here. Since we have P, so now here. Since now this, we are going to find this one as a function of Qj, lower Qj, and capital Qj. So this capital P here we have lower Qj, but we have lower P. Then we are going to replace lower P by this. So that means substitute equation 3 to equation 2. Then we have a capital Pj as a function of Qj, Ej, which is a Qj, capital Qj, and so that is equation 4. So we need to find the F1, but we need to first find the relation between capital Pj and F1. So if this F1 exists, then we have capital Pj to be partial, negative partial F1, partial capital Qj, which is a function of Qj, capital Qj, and T. Okay. Then if not, then that we cannot solve. Okay. So now that means if we can find this function, capital Pj is function of a lower Qj and capital Qj and T, then that means there must be a function in this function F1 partial, capital Qj is this one. So now step 3, we are going to find. The goal is find F1, since we are going to, then we are going to find this K, right? How to find F1? So, how to find F1 first? Let me look at it from equation, which one? Equation 3, right? We know Pj is a function equal to partial F1 partial Qj, right? Then that means if we do the integral, so partial F1 should be equal to integral of partial F1 partial Qj dQj. I do the integral, right? Both sides. And this integral, just keep that's equal to Pj right, since this Pj is partial f1 partial qj, therefore if I do the integral for the partial f1 with respect to the qj, then that is do, since this one we already have, right? Just do this integral. Then this integral, if you give a function, I'm going to say f. F is from depending on g, right? Fg. And this after integral is still function of qj, capital Qj, and t, right? But we have a constant. So this constant c, what is it, g, it must be function of, because this integral is this one, so that must be still a function capital Qj and time, right? Since we didn't do the integral with respect to capital Qj and time. So now you have this, that means, okay, so that means f1, so from here we do the integral, then give us f1 is this. But we do not know this constant. We can have this f1, since we do the integral, we can have some formula here. Then the c, we do not know, but we need, so now next year we are going to find this one. How to find this one? Next from, okay, and this is step 4. Equation here, capital P, equation 4. We have a capital Pj is negative partial f1 partial capital Qj, right? And then here, since we already have f1 here, even though we do not listen, but we know part of f1. So when we do partial f1 partial capital Qj is equal to partial fj partial Qj, that is Qj capital Qj t, and partial Cj capital Qj t partial Qj, right? We do not know this one, but we know this. So now we are going to find this one. Then this give us Cj as a function of capital Qj t equal to, we do this integral of partial Cj Qj t partial Qj and dQj, right? And how to do this? This one by solving this, because this one equal to this one we already know from equation 4. So right hand side we know, and right side we know this one, we do not know this one. So from this equation we can know this. That is move to, so that is a move to the negative, right? Negative partial fj is this term move to the left, partial qj, and just inside and just same time, right? This one and this term plus minus. Okay, here there's a minus sign. So that's be minus. Then this move to this side, so this minus is become minus. It's minus capital Pj dQj. Right, that is we can find this. Then when we have this, so then we have finally, okay, I'm going to write down here, f1 is function of fj, and this one is partial fj, partial qj, dqj minus pj, dqj. That is f1. Then step, this more step than the previous case. If you know f1 is simpler than this case. So now you are going to calculate partial f1, partial t. Right? So that is, you have to do this. If we say this equation number 4, 5. from equation 5, we obtain partial F1 partial T. Then step 6, we're going to calculate the Hamiltonian. New Hamiltonian is H now. Transformation equation. And here is the function of if we have this equation 6, so let's substitute equation 6 to here and replace the Hamiltonian old Hamiltonian in terms of old. I think here that we need also make a convert. Okay, here already is P and the Q. We can get Q from here. Q from here, right? You know P and substitute. So whatever we can see, you can 7. Same thing here. This is 7. Now up to here we have a 7 of this and 8 to this, so that we got this. The most important or difference is or partial is in this Hamiltonian. And how to get Hamiltonian? We either use the transformation equation to get the old Hamiltonian, the old general kinetic variable in terms of new kinetic variables. Get the general function, generating function, then you can get the k. Once we have a k, we just do the same thing. All the other remaining are same. Okay, this is the F1 case, and we just give a general discussion. And for details, we are going to use some of the example to show how we do that. So, okay. Now we go to next step is, so far we discussed is assume F is equal to F1. How about F equal to F2? What is equation for this equation of canonical transformation and the conditions? They are different. So let's play with that. Transformation. So how to make F2 type, we will apply the Legendre, just changing variables, right? Linear transformation. In chapter 8, we discussed transformation. That idea, if we have a function, f is a function of x, y, then we are going to transform to a new function, which if we keep y, but x becomes u. How to do that? Remember, in this case, so that is if we select is fx minus partial f partial x, right? So whatever is, if you want to change, replace x by u, and u is what? U is nothing but partial f partial x. So we are going to transform. If we just keep half of them, still keep the same, but another half we are going to replace by new variables. Then how to do that? That new function is old function minus its partial derivative with respect to this, the variable which we are going to replace and multiply itself. So if you remember this, now let's start from, so we can say if f corresponds to F. So F2 corresponds to G. Then very easily we can obtain F2 by this relation. So F2, remember F2 F1 is a function of QG, capital QGT, right? That is F. Then F2, we use still QG, but now replace capital QG by capital PG. So what we want to do is, you can see here, compare with this one, the X in our case is capital QG, right? And change to the capital PG, keep a lower QG instead. So how to do that? I follow this, so F2 is function of QG, capital QG, capital PG. P is F1, simply F1, which is function of QG, capital QG, T, minus partial F1, partial, I'm going to use, change this one, right? So partial QG. Here, I need the summation thing, they have all the J, right? So that is how to transfer, and then let's look at. So if this is F2 is this, then F1, QG, P, I move this to the right hand side, so that is F2. This one, so now, let me first write down. Fast, right? J partial F1, partial QG, QG. I just move this term to the left hand side. So F1 is like this. Then you know, what is one? And this here. So that is negative. This term is negative PG, right? So minus summation capital PG, capital QG. So now the relation between F1 and F2 is this. Then okay, then we are going to select the genitive function. Is F1. We still keep F1, so F1 replace now is replaced by F2. So that means here I convert, so initially F1, F genitive function is a function of QG, capital QG. But now if we set up, introduce F2 and plus this one, minus this summation, it will be a function of lower QG and capital P, right? So that is the transfer. And then because that's so, now let's look at total time derivative is partial, partial F2, partial F2 is QG dot, and F2 also is function of capital PG, right? PG dot and partial F2. Partial T, right? That is the F2. Total time derivative of this one is equal to total time derivative of F2 and this one. Then this term, if we do the keep a PG first, QG dot and minus keep PG dot and QG, right? So that is total time derivative of this genitive function. Then now we substitute into this initial equation or condition for this canonical transformation. We substitute this df dt to this formula. To save time, so this df dt is here, right? So now again, look the left hand side, we have a QG dot. So right hand side, the coefficient corresponds to QG dot is which one is this term? here, right? This one. And so that's the coefficient for Qj dot, that gives a Pj, this one, equal to this one, right? Partial F2, partial Qj. And, okay. This term also cancel this term, right? We just substitute this into here. This is a DFD here. This is 5 terms. So the 5 terms and this term cancel with this one. Then this one is Pj dot. So for Qj dot we have this one, and for Pj dot, left hand side we do not have. We have this Pj dot is this one and this one, right? So that's Pj dot coefficient is capital Qj equal to this minus plus Pj dot plus Pj dot plus this one, right? Oh yes, because they are in the same side. So that is constant, right? Partial. Okay, so we have this, and then you see the equation this time, this one also cancelled, right? This one cancelled, with this one cancelled, and this one also cancelled. Then you can see the remaining part is negative Hamiltonian equal to K, or negative K, this term, and this one, right? Partial F2, partial T. So again, if we move to K, new Hamiltonian is equal to old Hamiltonian plus partial F2, partial T. Do you remember the for F1? Same formula. The only difference here, this is F2. So whenever you F2, F1, the equation for the canonical transformation, the new Hamiltonian always equal to the old one plus the partial time derivative of F2, Geometric function. And so now, how many equations here? 1, 2, and 3. For F2. So you see here, if F2, this is a PJ, QJ. For F1, this is PJ and capital PJ. Right? So that's different. Then the remaining part is how to solve it with F2. Okay. I just give you the first few steps. The remaining, once we have a K, all the remaining part is same. So now let's discuss the steps or process. Let's only consider if F2 exists. If not exist, follow the similar things. So now let's consider. Let's just consider F2 exists. Then the step 1. Again, step 1 we apply the PDF equal to partial F2. Partial Qj, which is a function of Qj, capital Pj, hat. So that is equation 1. Okay, and step 2, we apply capital Qj is partial F2, partial capital Pj, which gives us function of capital Qj as function of Qj, capital Pj, P, as equation 2. So now with these two, we are going to find this transformation equation. Transformation equation is from transformation equation is here. This one is function is from 2. We have Qj is function of capital Qj, capital Qj T. That is the first half of the equation, transformation equation. Then this, if I combine from, okay. Step 4. Here, so that the PJ is PJ. Now QJ is any function of capital QJ, capital PJ, P, and capital PJ, P. That is equal to 4. So now, from step 1 to step 4, we obtain this, this one, transformation equation 3 and 4. Then step 5, that is a Q equations 3 and 4, 2 Hamiltonian, and F1, F2. So we have K, a new Hamiltonian, is old Hamiltonian. Now these are all in terms of the new canonical variables. Partial F2, which is also convert all canonical variables. Okay, so the remaining part is same. We will and then this for the step 6, 7. I think I also step 6 is solve the Hamilton's equation of motion, and step 7 is that solution transfer go back to this transformation equation again. So this same as for F1. So I just come. You just follow the F1 you already discussed right in details, so you can get this F2 same thing. Now that is F2 type. You see, F2 type is the mixture of old general coordinates and the new canonical variables. How about F3? F3 is we convert to old canonical conjugated momentum and the new general coordinates. So now if this is as a G, we are going to start from F1. We can do this because now F1 we keep capital G. We are going to exchange QJ and PJ with this, so similar things, right? So now what you need to do is F3. F3 this is a PJ. This is a QJ, right? So that equal to F1. Now we are going to replace this one, so this is a PJ, right? If you follow this, the F4 you can do yourself, right? So now let's see. Then with this one, now F, so here this is F3. I just move this to the right hand side, right? So that is plus F1. And this is 3. Now here, this term, F1 partial P is, remember, is Q, right? Sorry, no, F1 has no dot. F1 F1 has no to Q, right? The old one here. This is old one. So old one is this one, right? Not P. So that is Q. Okay, so then this one is P, right? Remember? PJ plus that's the QG. Okay, so then here S3 plus PG. Yes. Yes, plus. Okay. And you do the same thing here. So now this is partial F3. Now this is not Q, this is P, right? And this one is 3. This will be capital Q. Capital Q. And this is 3. And here this is a lower P. Lower Q. And the lower P. P dot. Lower P, right? In this time. Then right hand side. So now we use, let's do left hand side, we have a QJ dot this term, right? So then we have PJ. This case, we have this class, right? That's small. So this is class, but this is class. So then you can see these two cancel, right? This one cancel. And then the left hand side we do not have, so now we look at the right hand side. Right hand side, let's look at the PJ dot here, right? So PJ dot, and then we have a PJ dot. We have a QJ here, QJ, coefficient QJ equal to negative partial F3 with respect to PJ. That is these two terms, right? Then this for QJ dot here. So the capital QJ dot is a capital PJ here. QJ dot and capital PJ. Capital PJ, this one is equal to negative because this is in the same sign. This part, right? Then you come to see here the remaining part again. This disappeared, this cancelled, and only this term, and then plus this one. So same thing here. Then you can see here we get the same. And now we are going to study, in this case, if S3 exists, so what we are going to do is of F3 we have equations QJ and PJ, right? So QJ is negative PJ, right? So that is equal to negative PJ. And that gives us a function of QJ as a function of PJ and capital PJ. That is equation 1. Then again, second one is a capital P. Capital PJ is this equation here. That equal to negative partial H3 partial capital QJ. So which is again the function of signs, right? Then we come down to here. So step 3 again from here, we are going to find P, right? So here P is function of a capital PJ, QJ and capital PJ. That is one of these transformation equation. That's equation 6. So do the same thing from 2. Then sub 3 to 1, so then the QJ is PJ, right? So PJ is here. So QJ is PJ. So now this is a PJ. PJ is a function of capital PS, and then this is a QJ, right? Yeah, this one. So get this. Then sub 3 and 4 to the Hamiltonian and F3. Then we have this. The remaining the same. The last one, F4. F4 is, if you remember, F4 is a mixture of lower P and capital P. Right? So you can see from F1 we cannot transfer to the F4 because 2 no change, right? So we cannot use this is only half change. Then which one we can use? F2 is QJ capital PJ. Then if we want to convert to the F4, which is a capital PJ, so this keeps same. We only exchange QJ to PJ. So if this is as F function, then we have F4, I follow this. So F4 here. Equal to, now this is a 2, not 1, and not the 1, right? So 2 is, then if we change Q by P, right? So this term is the same, but here is F2. Then the F, so then the F, okay, let me first, so F2, I move this to the right hand side, is F3, F4 plus F2. Okay, then here, F4, okay, this is and this one, partial F2, partial is positive QJ, right? PJ, you can remember this one is PJ. So that is this one. Here. Then now we come to here. So this one will become okay. So F1 equal to F2 plus minus F1. F1, remember F1 equal to F2 minus summation capital PJ, capital QJ, right? And now the F2 here is this one, so we substitute this F2 by F4. F4 and plus summation lower PJ and lower QJ. This term. And keep this term, minus. Okay. We have another class. So this is a GNP function. Now the remaining part I want you to do yourself. Let's first do this total time derivative. Do this. And then substitute this term into this condition. Then you are going to find something like this equation and find this. So we are going to keep continuing on Thursday. But I would like you to play this one. I just gave you a summary on Thursday. I would like you to do it yourself. This kind of practice. This definitely will go to exam, final exam, so I want you to play familiar with those. Okay. And I think
our final exam will be closed book or
Sorry?
our in-person exam is closed book or open book exam?
in person close to,
Closed or open book exam?
yes, it's an open textbook, open notes, open your homework, everything's open.
class? For
In
the
class,
airport?
yes.
Oh.
Yeah, you can bring what the material you want.
Okay.
Just,
fine.
yeah.
They can use it. Okay.
When is the final, right? I think our last class December 1st, I remember. That is Thursday. Then next week, after that, the next week, the following week, Monday is another class. So
Should be
Yeah.
December 8th.
December is a
That's
Thursday,
it.
right?
Yeah. That's
Yeah.
it in class.
December, yeah, in class, December 8th. I think I will, yeah, you can write directly, but we will announce it, make a final decision. But December 8th is, so far, is the idea.
Okay.
Yeah, that is just Thursday after the final class, 1 week after that. Yeah.
What
And,
time?
yeah, what time I'm going to make with Mishi. We have some other class, maybe use the same room. So she will make a schedule.
Okay.
Yeah.
Good, good.
The final exam for the Dr. Jenki's class is the last day of the class.
For mathematical?
Yeah, mathematics.
That's December 1st.
Okay, so the last day of this.
Yeah, so it won't conflict with.
Okay, then you have a time to
Yeah.
prepare. Okay. Can I erase now?
Yeah.
Okay.
Thank you for being considerate.
Yeah, you're fine. Yeah. Sorry, I also want you accept my speed now, speed up a little, so because I want to cover the chapter at least 9 and 10 the first if it is possible, but I can't. Oh no, next week, after next week, I almost go to Thanksgiving. Wow, that is almost so. I'm not sure we can finish chapter 9. Let's see.
Time flies when you have fun.
Sorry?
Time flies when you're having fun.
Yeah.